Hello everyone. As I mentioned in the community forum, I would be defending both the answers as correct for this question, and I rather recommend NTA to drop this chemical kinetics question altogether because there is an ambiguity in the question itself. It is not due to stoichiometry, it is due to the value k given. The k given is not mentioned as K effective or true reaction rate constant. We don't know that. They just simply mentioned it as K. But if we consider stoichiometry, then this K would become true reaction rate constant, which is different from K effective. This is if we consider stoichiometry. On the contrary, if we don't consider stoichiometry, then K would be K effective. It won't be true reaction rate constant. Irrespective of that, there is one thing that everybody can agree is, whatever be the stoichiometry, a zero order reaction takes exactly 2 times the initial half-life for 100% completion. This is a statement that everybody can agree, isn't it? Whatever be the stoichiometry, a zero order reaction takes exactly 2 times the initial half-life for 100% completion, which we can mathematically prove it. So let us say we have the following reaction, A times A giving products, which is a zero order reaction, and K is the true reaction rate constant. So in that case, the final concentration is equal to minus A times K true reaction rate constant times T plus initial concentration, isn't it? And at T equal to T 100%, the final concentration would become 0. So therefore 0 is equal to minus A times K true reaction rate constant. I am just writing it as true. So it is a true reaction rate constant, not the effective rate constant, times T completion plus initial concentration, which means T completion is equal to initial concentration divided by A times true reaction rate constant. To find the initial half-life, let us set the final concentration to half of its starting value. So therefore, this would become exactly half, isn't it? When T equal to T half, that is something we all know. So therefore, half times initial concentration is equal to minus A times K true times T half plus initial concentration. So therefore, A times K true T half is equal to half of initial concentration, which means T half is equal to initial concentration divided by 2 times A K true reaction rate constant, isn't it? So now if we divide both the things, so let us say if we divide T completion divided by T half, what we would get? We would get that initial concentration divided by A times K true times 2A K true divided by initial concentration. So therefore, what we have is 2 times T half. I am just trying to prove the statement mathematically. The statement we had is, whatever be the stoichiometry, a zero order reaction takes exactly 2 times the initial half-life for 100% completion. So therefore, by considering stoichiometry, if we do consider stoichiometry, then T half will be initial concentration divided by 4 times K true, not 2 times K true. It would be 4 times K true if we consider stoichiometry. This is the relation that we use, isn't it? So therefore, T half is equal to initial concentration is 2 molar divided by 4 times. Now K true value is given or K effective value is given. We have to presume that they have given K true. So therefore 1 molar per minute, which means T half is equal to 1 by 2 minute. Everything seems to be okay here. So T half is equal to 0.5 minute. Now the issue is we have to assume that the value given, the K value given in the question is true reaction rate constant. On the contrary, if we think that this K value is K effective, then what will happen to the true reaction rate constant? Then K true will be half, isn't it? If we assume that whatever be the value given there is K effective, then K true will be 1 by 2 molar per minute, isn't it? So if we substitute this K true value here, then we can't get T half equal to 0.5 minute. Do you understand? What will happen in that case? In that case, we will get that T half is 1 minute, isn't it? So therefore, the ambiguity comes because the question paper doesn't say clearly whether the K value given is true reaction rate constant or effective rate constant. Now let us think on the other way around. So let us say we don't consider stoichiometry. So in that case, T half is equal to initial concentration divided by 2 times K effective. Once again, we don't know whether K is K effective or true reaction rate constant, we don't know. So if we just substitute the value 2 molar divided by 2 times 1 molar per minute, then we are getting T half is equal to 1 minute. If T half is 1 minute, then T 75% will be 1.5 minute and T 100% will be 2 minute. This also looks okay, isn't it? So this is the reason I am saying both answers we can comfortably defend mathematically. So for that reason, I think NTA should drop this question because they did not tell us whether this is the true reaction rate constant or effective rate constant or observed rate constant. Both are one and the same. Effective or observed, both are one and the same. So we don't know whether it is a true reaction rate constant or effective rate constant. So for this reason, I say that there is an ambiguity in the question itself, and that's the reason NTA must consider about dropping this question altogether, and everybody should be given +4 marks.